Hey, kids. It's time for another spine-tingling episode of, well, whatever we call ourselves. This time we're going to be looking at another LeetCode problem. It's called, and it's the third problem, longest substring without repeating characters, which asks, given a string S, find the length of the longest substring without repeating characters. So what do they mean by that? Say you have an input string S, which is ABC, ABC, BB. The output, meaning the longest substring length, is 3. So that means we got to ABC, and suddenly we saw another A over here. So the length of ABC was 3. We got to another A, that's 4, but that's not a valid string. Now, even if BCA is also valid, the length is also 3, so that doesn't beat the ABC string. Now here you have a bunch of B's repeated. The longest substring length before another character is repeated is 1, because you can't have two B's. Finally, here they tell us that the longest is KEW or WKE, it doesn't matter, and that's 3. So you can't have these two W's repeating each other or whatever. And finally, we have this input S equals nothing. That means the longest substring length can be 0. So whenever I have a problem that asks for the longest this or the maximum this, I always write out my own little function here, since yes, we have it in the standard library, and why reinvent the wheel, but I like writing it here because it kind of gets me into the flow of things. So let's just write it here. And it takes in 2 integers by reference, and we use the const just to keep it clean, as it were. So we say if A is bigger than B, return A, else return B, and it's that simple for that. Now let's start with our base case, which we'll just get rid of right now. If the string is nothing, then we return 0 if it's empty. So that's exactly how we're going to write it. If s.empty, return 0. Otherwise, well, how are we going to solve this? When we look at the particular string like ABCA or something, we'll iterate through this string S, and we'll start adding to a new string. So we first see the character A, we'll add to that if we're looking at this particular string. And if we don't first see the character B, we'll add to that. If we see the character C, we'll add to that. Whoops, suddenly we have another A. We see that there's another A here. Our method here is we take the length of the current string and we compare it to our current longest. And if it's bigger, that the current longest becomes the current length of the string. But whatever the case, we eliminate this A, and then start counting again from the first element of that current string that occurred after the repeated character, or the first instance of the repeated character. Suddenly, there's no more repeated character. We only have a new one. So I hope that made some sort of sense. Let's just keep that comment there as to how we're doing. So, and we'll just say delete A before inserting the other A. So let's come up with that current string that we were talking about, which we'll call appropriately current string. It's a good idea to come up with these initializers over here. For default types, it's going to set them at whatever it's supposed to. For example, integers, it'll set them to 0. Not all compilers work that way. We'll also come up with a current max, and at the end of all this, we'll have to return the current max. So all of that's fine. So we said we were going to iterate through the string. Okay, this is the default way of iterating that's recommended in various books. So it's as if when you're viewing the elements, the current character of the string, it's as if it's passed on by reference, not as if it is, as it were. And so there's no copying done, or needless copying. So that's all good too. The first thing we're going to do is we're going to check, hey, have we seen the current element, which is a character? So this is what we're going through every character of the string. Has it already seen this character in the current string? Now, the first character, we know it's nothing, but we still need to write the code. We could use our cool auto keyword. We'll do, and we'll say found position equals, we have an algorithm for this, which is find, and find in what? The current, from the current string dot begin to the current string dot end, and we're looking for this element. Now, there's two possibilities. If it has not been found and if it has been found. So let's write that down. If it has not been found, so if we got to the end of the string and nothing got found, then we do something else. It is found, and we do something else. So what do we do if it's found? All we do is we add the element to the current string, meaning the current character, we add it to this current string character. So current string plus equals element. We could do this. We're adding a character to the current string. We could do that. And at the same time, after that's added, we'll compare that to the current value of current max, and actually we should initialize it at 0. Current max equals, we'll use our little max. It's the biggest between the current max as it is now and current string dot size. Okay, now if we did find the element, here's where the magic happens. Now we're going to erase that little a before inserting this a to the BC over here. So how do we do that? We already found that first a in the string, and that's this position over here. That's where our iterator is pointing at now. So we say current string dot erase, and we erase everything from current, from where? From current string dot begin to found position plus 1. So the plus 1, I have to admit, I had to play around with this before making this video, but you'll see why, so it makes sense. It's as if when you look at the end over here, if you try to dereference that and get the actual value, there's nothing at that end. What you really want is you want to start with what happens after whatever you deleted. So this deletion is inclusive, so you have to start, you have to get to that end over there. So, okay, after all of that, so you could play around with that and see what happens if you don't do the plus 1. After that, we do the same as before. And we do that same comparison. In fact, I could have just copied and pasted here. And we do it here. After all this is done, I believe we're good. So 2 situations. We look for the character. If it's been found, if it hasn't been found, then we just add the character to the current string, look at the length of the current string, and compare it to the length of current max. If it's bigger, then current max becomes that current string size or length. And if it has been found, then we erase everything up until the position of that found character. We add the new character, and we take the new size again, and we compare it to current max. And let's see what happens when we run the code. Everything works, and we submit. Well, kids, that's it. As you could see, good running times. Have fun.